I want to take a look at histograms again because sometimes some things come up with histograms that, let's just say, you may want to know something important. In particular, it's called a log histogram. And this is useful whenever your histograms are they reveal skewed data. So I'm going to include this in the same notebook because I want to use the same data set, okay? So what I'm going to do here is the following. I want you to do it with me. Go ahead and title it. I want you to include a log histogram title, maybe even a plus log hist. Why? So that later, if you were like, oh man, I don't know where the log histogram is, you can find it, okay? So first of all, what is it? When would we need it? Well, let's actually, it's often, you want to use it when there's skewed data, very skewed. I was guessing, well, maybe capital gain is skewed, right? A lot of people have a little bit, some people have a lot. So what we're going to do is actually plot a histogram of capital gain. And let's go ahead and try to make it decent looking to start with. So what do we need? Import matplotlib.pyplot is PLT. There it is. I'm going to move this up. Code with me. Import Seaborn as SNS. SNS.set. Get that nice dark grid. PLT.figure, fig size. And then I remember liking something like 11 and 6. And then plt.hist. And the histogram is going to be df capital gain. There it is. I sometimes type slowly when I want it to show up. And then plt.show. So I think that should show something decent. So let's look at it. Okay. So you can see it as a histogram, but it's like, it's not particularly revealing of the data. Okay. One other thing here. You need to comment on your histograms, okay, using text cells. So let's start that practice now. Why? Because it's just standard, and you're developing kind of expertise with data, and commenting on data is a part of that. Like, you need to know what this means. If you don't know what it means, it's almost worthless. You know what I mean? Don't let somebody else figure it out. You figure it out. I mean, we're going to try to figure it out together, right? I'm not expecting, oh, everybody can properly interpret this. You know, I get that it's new for a lot of you, most of you. And so it's a little help. So what do we have? Well, recall that the Y column for histograms is basically like the count. So let's look at that X. It looks like that's 20,000. So what this is saying is that, hey, the number of people who have a capital gain of between, like, say, 0 and 10,000 is over 30,000. When we look at the amount between 10,000 and 20,000, I mean, it's too hard to tell there, right? Is that 500? I don't know. But then notice that you have all these other numbers. Well, why are they there? Because there are entries there, but they're actually so few that you can't actually see them. They're not tall enough. So how do we correct this? We correct it by using a log scale. Now, do you know what logarithms are? Well, first of all, let me clarify again why with a text cell, okay? So I'm commenting on this histogram. So this histogram is it's skewed to the right because that's where it's being pulled, okay? It's very skewed to the right. And let's say what that means for people, right? Let's help interpret. Indicating that very few people, right? Because the Y values are so low. I mean, I'm telling you, when they show it to you on pandas, that means values are there, okay? They don't just like stretch it out for no reason. So it's very skewed to the right, indicating that very few people have a high capital gain. You don't have to go the deep in with comments. Just say something that's constructive. Okay. So that's a totally good comment. And again, why am I doing this? Because in your final projects, you are going to say something about the graphs. Okay. It's important, right? Okay. One other thing first, though. Aren't you interested how this breaks down? Right? Like 0 to 10,000, like can we get it thinner? You can, and it's a keyword bins. Okay, so up here, you can change bins to, and you know what? I'm actually going to do this in series. So let's copy. I'm going to recopy it. And again, maybe I don't want to clutter it up because I know it's in series. So I just copy these three. Okay, the others are going to set. And I go down, add a new coding. Nope, that's the wrong place. I can just use the arrow to move it. Put it in here. And then I can set the number of bins, okay? I forget what it is by default. Let's just try 50. I think that's more bins. We'll know when we look at it. So bins means basically like how many of those vertical bars are we going to have? All right, let's try that. You can pick another number too. Interesting, right? So it's got a lot more bars, and you can see, as expected, yeah, most people have hardly any capital gain. That's just the way it goes. And you know, there's some like scattered ones down here, but they're very low. So this is no good. I mean, when I say it's no good, it reveals a little more information, but we want nice looking histograms to capture that information. And so the answer is to use a log. But before we do that, make a comment. Okay, I want you to get in this habit. So what do I comment? I want to comment on the change. By adding more bins, by the way, when we're doing this right now, you don't have to make a comment right now. Okay, I encourage you though to think about what you would say. I encourage you to make a comment and even make one different than mine. You may have different insight. You can use my same comment too, it's all fine. Okay, so the point is we're all learning, okay? By adding more bins, we can see that most people have close to 0 capital gain, right? Right? And that's the point. So new graph, little difference, new information. You can have fun with bins, by the way. You totally like interesting things will happen. Highly encourage you to mess around with that parameter. Okay, so how do I fix this? It's log. And again, what is log? Okay, we need a quick review. I want it to make sense to you. I'll even give it its own header. Log histogram. And then add another text cell. So let's just consider base 10. So log of 10, well, 10 to the first power is 1. Log of 100, 10 to the second power is 100 is 2. Log of 1000 is 3, and so on. This is base 10. I think they may use base E, but it's the same general idea. And remember, if I compare left and right, I want to do double returns because the right is actually the output. So instead of like see, go back up here, right? So like this is 30,000. Well, it's going to be like 5 or something. You know, maybe a little more if they're using base E, which is about 2.7. But it's not going to be crazy high. And if that's like 5, right? Well, we should be able to see the values that are like 1 that are far to the right. Okay, so whenever you have skewed data, just try this. Okay, so let's try it again. By the way, this idea of commenting is I definitely distinguish between notebooks that are like going to be published for others and notebooks that are kind of like you're just adding code and exploring code and learning quickly. Okay, because like if I go back, I'm going to tell you I'll add in like text headers and other things to make this even more legible. Right, like what am I doing here, right? Well, you would want to say. So the bins, I mean, we could keep or not keep. I mean, I'll try like 40 this time. See how it looks. But then there should be a log value. See, log, look at that. Log equals. And you can better believe we want it true. I'm excited to see how it looks. Suspense. Okay, do it without me, right? I love it when you guys get the first crack. It's just nice to see, right? Like, is it going to work? Is it going to like really be revealing? Does this guy know what he's talking about? I don't know. And I don't know because I just know that log works for this situation in general. I don't know what it's going to look like here. Here I go. Look at that. That's much, you see how you can see the distribution much more? I like that. Now, maybe the 40 is too much, right? See, look, some people have a lot, right? Look, like over 100 people, they have a lot, and there aren't a lot in the middle here. And you know, you could maybe, is 20 the default? I'm gonna try 20 here. Just mess around with it. I think that looks better. I'm sometimes biased with how it looks. I mean, you can't control like the distribution is what it is. You know what I mean? But the bins, modifying the bins, make it look a little cleaner. So look at that. I put in 10 there. That looks clean, right? So you want to find a balance between like looking clean and looking accurate. Because you could do like 100, and you can get really thin ones. It's a little more accurate, but it doesn't look as good. I may try 15. That's what I mean about, I've talked about this with you guys, like tweaking to try to like find it. I like 10, 12. And you could try without bins, like just the default. Doesn't 10 look the best? I think so. I like it. I mean, it adds kind of symmetry, and then it is accurate. Okay, it's just not providing as much detail. Okay. Anyway, that is how you use, that is the way to show all the information in a histogram with skewed data. You want log histograms, right? So this number 10, it is doing base 10. So 10 to the fourth, right? That's 10,000, okay? It's 10,000, right? But the point is you can see under 10. That's the beauty of it. So be sure to use log histograms when your data is very skewed. It'll look better. And definitely play around with the number of bins. Very fun. It can really help you get the figures kind of the way you like.